Okay, next is lab 8, which is inertia in rotational motion. So this is long report. And for this lab, our lab objectives is students should be able to demonstrate and determine the moment of inertia as systems inherit pinpoint masses in a function of mass and radius, comparative investigations of solid and hollow cylinder. So our experiment setup include the apparatus of rotation body, which is a hollow cylinder, and we have pulley drums over here. Okay, pulley drums with diameter of 40 mm, and we have guide pulley, which is over here, the pulley that will guide our rope and our mass. And we have stand rod. Okay, we have a stand rod in our apparatus, and then we have bench clamp. Number 5, bench clamp is over here. Okay, this is our bench clamp. And thin wall pipes. Okay, thin wall pipes is 55 cm length. Okay, and diameter of 10 mm. And we have solid cylinder with weight of 0.9 kilogram and diameter of 120 mm. And we have a weight which is 100 gram, 200 gram and 400 grams that will be used for this lab. For test 1, we will measure the system inherent moment of inertia, in which we have the apparatus of thin wall pipe. Okay, so what we're gonna do is we will fasten this thin wall pipe until the middle. Okay, the middle of the pipe, and then we just tie it properly. Okay, make sure it is really in the middle. Okay, and then we have a rope that we already tied over here. Okay, we have this rope and this guide pulley, and also we already tied this 100 gram mass. So what we're gonna do is we want to measure the time that will be taken for this mass from one height to another height. Okay, so what we're gonna do is we're gonna rotate this thin wall pipe, okay, up to the height that we set. Okay. Okay, and then for example, we set it over here at this height. Okay, and then we're gonna take our stopwatch and then start to record the time that this will be fallen. Okay. So then we start, and then we stop. So, and then we're going to have to write up our table 1, in which, in table 1, we have a results of mass, which is 100 gram, and the time taken for the mass from one height to another height. And that's all for the calculation for table 1. Okay, now we are going for test 2, in which we have a pinpoint masses, I, which is the moment of inertia, as a function of mass, in which we have these thin wall pipes that already been placed over here. Okay, so we still place it in the center of the rotation angle. Okay, and then we're going to place our 2 weights that have the same mass. Okay, so for this one, we're going to use this 200 gram mass, okay, and we're gonna place it in the radius of 200 mm. Okay, so from here to here should be 200 mm. Okay, so we're gonna place one of the mass, and then tie in properly, and then we're gonna take another one. And then place it in here, tie it properly, and then we will do the same things, in which we have this rope, and then it's tied to 100 gram weight. Okay, and then gonna rotate this up to the height that we set. Okay, for example over here, and then we take our stopwatch and then start until it goes down to the height that we set. Okay, and this mass will be changed to another mass, and we're going to repeat the measurement of the time 3 times to reduce the error. And all the results will be calculated to get the inherent moment of inertia formula, and then we will write it in table 2, which is the results for test 2 for different mass and time for specific height. Okay, that is for test 2. Then for test 3, in which we have a similar setup, this is pinpoint masses. We will measure moment of inertia as a function of radius. Okay, so what we're going to have here is we're going to use weight of 400 gram mass. Okay, both are 400 gram mass. And then we're going to measure the time for the weight to be fallen with different radius. Okay, the first radius that we will take is 0.055 meter. And then we're going to change to 0.095 meter. And the last one is 0.245 meter radius. And then when we get the results of different radius, and then we will write it in table 3, and then calculate for moment of inertia I using the formula. Okay, now we are in test 4. Okay, test 4, we're going to have a hollow cylinder and also solid cylinder. Okay, so the same things that we're going to have to measure, which is the moment of inertia. So first, we take this hollow cylinder. Okay, and then we put it over here in the middle, and then we tie it properly. Okay, and then our weight is here 100 gram, and then we're going to do the same things, and then set our height, and then take our time where the mass will be fallen to the set time. Okay, once we finish this, okay, we're going to put it in our table 4, which is results for test 4. And then we're going to change to our solid cylinder. Okay, this one. Okay, we place it over here and we do the same procedure. So that's all for test 4. Thank you.